Okay. This is at the bottom of page 18. And they're saying if you look at x cubed plus 2x squared minus 13x plus 10, and there's three factors, so in other words, it can be factored perfectly to be x minus 1, x minus 2, and x plus 5. We talked about yesterday how we knew that there was no more factors, right? We know that there can only be 3 because if you look at your first value, which is x cubed, the only way you could get that is by multiplying x times x times x 3 times. Any more x's, you would have x to the 4, x to the 5, and so on. We also talked about how we would know in this situation that x plus 7 could not be a factor. You would never try x plus 7 as a factor. Why? Because 7 is not a factor of 10. So whatever number is here, that tells you possibilities for there. And this is called the factor property. If something is going to be a factor, if x minus a is going to be a factor of the polynomial, then the a value has to be a factor of the constant term. And that shows up in the purple. So when we're going to be asked to factor things completely, our first clue is the last number, the 10. What are possible factors? 1, 2, 5, and 10. So once you know what the possible factors are, then you can either use synthetic division or the factor theorem, remainder theorem, to find your first one. So here's what we've been leading towards. These questions that say, oh, we did this one already. It's not the one I want. Factor fully. And as far as things go, factoring fully, this is going to be one of the easier ones. Because what's our last number? A 2. So if we wrote them out, what are possibilities for that last number to be? 2 and 1. So the fact that this is a 2, they could be 2 and 1. Do they have to be positive? No. So it could be plus or minus 1 or plus or minus 2. And generally what we do to figure out which one works, I'm going to let p of x equal this, is we start with the 1s because they're easier to do the remainder theorem. If you're going to use this, if I'm going to say p of 1 equals, well, you are introducing p of x. So the word let says I'm introducing this. Let p of x equal this because it wasn't given in the question. If you plug in 1, can you see that you would get 3 minus 4 minus 5 plus 2? What does that equal? Does it equal 0? No. Not equal to 0. So we know that x minus 1 isn't a factor. Try minus 1 next. You would get minus 3 minus 4 plus 5 plus 2. Does that equal 0? Yes. And although you could keep trying with 2 and minus 2 to see if you find another one, your goal is just to find your first factor. Once we find one factor, we're going to use synthetic division and write the division statement. So now that I found out that x plus 1 is a factor, okay? If you like writing steps, If you like writing steps to things, 1. And we're going to use synthetic division and write the division statement. So we've done step 1. Now we're ready for step 2. Synthetic division, 3, -4, -5, 2. I did a quick check to make sure they were in order, and I did a quick check to make sure that I didn't have to write zeros for anything that was missing. And since we know x plus 1 is a factor, what number would I write outside here? A -1. If this was done correctly, we should get a remainder of 0. Yes. Okay. The other nice thing about writing let p of x equal the whole thing that we started with, in our division statement, you can write p of x instead of having to write all 4 of those things, is equal to x plus 1 was our factor that we found, and we're left with 3x squared minus 7x plus 2. It said factor completely. Well, now, as soon as you get to a quadratic, you can go back to your old methods of factoring. So this is just 3x and x, 2 and 1. They'd both be negative. Multiply that out to make sure that it works, and it does. Right? If you FOIL this out, right? If I multiply this times this, does that give me 3x squared? If I multiply the outside and the inside together, does that give me minus 7? Yes, it does, minus 6. And then do the last ones give me plus 2? That's right. Look at all of our last numbers, which we had underlined in purple before. I'm going to get rid of those arrows. Right? All of our last numbers, -2, -1, and 1, do they multiply to give us positive 2? Yes. And that's what we had started with here, a positive 2. So that last number is the key to finding one factor. Then once you've found one factor, use synthetic division and write the division statement. Step 3, you can either, once you get there, you can factor it completely, or you might have to repeat steps 1 and 2. In this situation, once we wrote our division statement, this was something you already knew how to factor, so it was just factor it completely, you're done. But you will get some that start with an x to the 4. After you find one factor, you still have an x cubed. And then you can say, oh, pick a different letter. Let h of x equal that. And do this process step 1 and 2 again. If you started with an x to the 6, you'd find one factor, then have an x to the 5. Do it again. Then you'd have an x to the 4. Do it again. Then you have an x cubed. Do it again. And then you have an x squared and factor it completely. Yes, then yes, then yes.
So if you change the variable for each time that you have to repeat steps 1 and 2, then what
So if, let's see, do I have, maybe I have one here. Do you want to do one with an x to the 4 as an extra example? Okay. Ooh, I'll make up a new one. Let's do factor. I'll do one where you could do a shortcut, but I won't show you the shortcut. I'll leave that for you to see if you can figure out on your own. You can write this wherever you like. Okay? After scroll up on this one to get the steps. Okay.
I need a chance just look through this, make sure. I saw Ben was missing
Okay.
from mine.
All right.
I don't think Selva's in there. Maybe it's because she's not writing exam.
Maybe not. Yeah.
She might be there. I might have missed it. but
Okay, I'll
give
check
back
it.
to Jen when you're done. I think that's for exams.
So we look at the last number. What are the possibilities to get 6? One. Oh, maybe I'll change this. I'm going to change the numbers. Sorry, guys. I want it to work out even nicer. Okay? I know. I shouldn't do this. How big of numbers do you want to work with? Tiny? There we go. That's better. Small numbers, not so bad. Okay. Look at your last number. What are possibilities? 1, 2, and 4. Mental math-wise, what number do you want to try first? 1? Perfect. I'm going to let p of x equal this, and we'll start by figuring out p of 1. That will be 1 minus 5 plus 4. Yes, good choice, guys. It works. What does that mean? So, x minus 1 is a factor. We've done step 1. Step 1 was finding a factor. I'll write that in green. Step 2, now use synthetic division and write the division statement. So here we'd have 1. We have 0x cubes minus 5. We have 0 x's and 4. Would you remember to include the zeros? And a 1 goes out here. Bring down the 1. 1 times 1 is 1, add. 1 times 1 is 1, add. Negative 4, add. Negative 4. Yes, we get a remainder of 0. Write your division statement. P of x equals x minus 1, and you're left with x cubed plus x squared minus 4x minus 4. And above this, I'm going to say, oh, I wanted purple. Let h of x, I don't know what letter, whatever letter you want other than p, because you've used up p already. Let h of x equal that. Can you see this isn't something you know how to factor? So we have to repeat the process. We have a new last number now. It's negative 4. From that new last number, it still could be plus or minus 1, plus or minus 2, or plus or minus 4. What number do you want to start with? 1. So now you try h of 1. That would be 1 plus 1 minus 4 minus 4. Does that equal 0? No. That means x minus 1 is not a factor again. What number would you like to try next? We've tried positive 1. You want to try negative 1? Negative 1 cubed would be negative 1. Negative 1 squared is positive 1. Negative 4 times negative 1, positive 4 minus 4. Does it equal 0? Yes. So, x plus 1 is a factor of h of x, which means it's also a factor of p of x. Now we can repeat step 2 for h of x. So this was step 1 repeated, step 2 with h of x. Hello. Synthetic division for the purple, for h of x. Somewhere I put down my pen. Oh well, we'll find it. So h of x was 1x cubed, 1x squared, minus 4x minus 4. We're dividing by x plus 1 because it's a factor, so minus 1 would go to the front. Bring the 1 down, multiply, add, multiply, add, multiply, add. Sure enough, we get 0 as a remainder. Now, when you write your division statement next, you can write p of x again. We already knew x minus 1 was a factor of p of x. And now h of x is x plus 1 times x squared minus 4. And now we can factor this completely. Because it's a difference of squares. Oh, good. Found it. Questions for practice? Where did this x plus 1 come from? That one came from here. We just found out it's a factor. Okay, questions for practice of this example are 5, 11, 9, and 10b. And I will